Okay, class, we're about to start section 1.4. We are going to cover sections 1.4 and 1.5 today, but if we get a little overzealous, we may even cover 1.6. You never know. But I'm looking to at least get us through 1.4 and 1.5 because I know we do not meet on Monday for the King holiday. All right, so 1.4. It says, take a guess. Our learning objectives is to make educated guesses in a variety of settings and to estimate locations on a number line, compare numbers using inequality symbols, and approximate square roots. Okay, we're going to look here at the bottom. It says an isotherm is a curve on a map that connects locations where the temperature is the same. By looking at a large map with isotherms, you can get a rough idea of what the temperature is like in many different locations. Using the map below, estimate the temperature in each city. Okay, so now when we look at this map here, Las Vegas is the capital L. So we look here at the capital L, it's exactly on this line here. So that means that it's actually 40 degrees. Phoenix, Arizona is the P, the capital P. If you notice here, the capital P is in between 40 and 50, but it's closer to 50 degrees. So that'll be about 48 degrees. Dallas, Texas, the D, if you notice, is right in the center between 20 and 30. So that would be 25 degrees. Springfield, Illinois, the S is between 0 and 10 degrees, but it's closer to the 10 degrees, so we would say it's 8 degrees. Atlanta, Georgia, which is the A. We look here, the A is in between 30 and 40. It's closer to the 30, so it's about 33 degrees. Miami, Florida, the capital M. It's a little bit above the 50 degrees, so I would say it's about 51 degrees. And then New York, it's in between the 0 and negative 10, closer to the 0, so I would say it's negative 2 degrees. All right. So that took care of that, which is page 45. So we move on. Now, our next page, we're not going to do anything else on this section until we get to page 48. Now, on page 48, you notice here that we have a picture here of using technology, approximating square roots. Now, you can use a TI-84 calculator if you so choose. That's fine. However, I basically use Desmos for this class. I can occasionally do a few things on the TI-84 if there is a need. Is there anyone that's working with a TI-84? Okay. All right. Now, I would tell you, occasionally I will go over using the TI-84, but the main calculator that will be used for this course is the Desmos calculator. But let me pull up the TI-84. See if I could pull that up. Okay. Now, does this, oh, well, wait a minute, it won't let me. Okay, it looks as though every time I move it, it wants to jump right back. Oh, okay, maybe I could go up a little bit. Okay, great. All right, for those of you that had a TI-84, now you may have the color one, but doesn't this look similar to the TI-84 that you have? Okay, so what I'm going to do, I'm going to navigate in between the calculators. So, oh, that's interesting. This screen froze. So let me pause real. Okay, we're back. The screen is not frozen anymore. So like I said, what I would do, I will navigate between the two calculators. All right, so it says here, complete the table by following the instructions in each column header. It says fill in the correct value to make each equation true. No calculators. All right. I can't hear you now if you're talking. You can't hear me? Oh. Okay, for some reason, no one could hear me talking. It's the technology, but now we're back. Okay, so it says here, number 20, complete the table by following the instructions in each column. Fill in the correct value to make each equation true. No calculators. Okay, if you notice here, it goes the answers 1, 2, 3, 4, 5, 6. Then we could guess that this would be 7, 8. This would be 9, 10, 11, 12, 13, 14, and 15. As they told us, don't use any calculators. So we can make a guess there because it looks like it's going in numerical order. Now, we have the square root of 1 is 1. The square root of 4 is 2. The square root of blank is 3. So remember, with square roots, we're trying to find a number multiplied by itself that would give you the answer that's under the radical. So 3 times 3 is 9. So we're saying the square root of 9 is equal to 3 because 3 times 3 is equal to 9. Here, 6. You got to think about it. 6 times 6 is 36. So the square root of 36 is 6. Then we come here, 12 times 12 is 144. And then the square root of 144 is actually 12. And then 15 times 15 is 225. So the square root of 225 is 15. Now we come here to the middle section. It says estimate each square root to the nearest whole number, then write a statement using greater than or less than to indicate whether your estimate is more or less than the square root. So I'm assuming that they do not want you to use a calculator here. But if you look here, the square root of 9 is 3, right? The square root of 16 is 4. Now we know to get from 9 to 16, what's that, 7 numbers there? And this right here, 11 is closer to the 9 than it is to the 16. So this we would assume is approximately 3. So they ask us to use a greater than or less than symbol to indicate whether your estimate is more or less than the square root. So we know square root of 11 has to be greater than the square root of 9. So the square root of 11 is greater than the square root of 9. And just remember, this symbol here always points to the lower number. Square root of 78, we go here. 78 is in between 64 and 81. It's closer to 81 than it is to 64, so it'll be approximately 9. So now we need to write a statement here. So we would take 9 is actually greater than the square root of 78. Because if you look at the number 9, it was the square root of 81. The square root of 81 is bigger than the square root of 78. And let me go back up here and correct one thing. I should have written this as the square root of 11 is greater than 3. That's how I should have wrote it. So that's how you should write your answer. Now we go here to the square root of 99. We know the square root of 99 is real close to 100. So it'll be approximately 10. So we would say the square root of 99 is less than 10. Now the square root of 124 is very, very close to the square root of 121. So it's approximate 11. So the square root of 124 is greater than 11. Does everyone follow that? Okay, now we come here to the next side. It says use a calculator or a spreadsheet to approximate the following square roots to the nearest hundred. Now I'm going to show you how to do this on both the Desmos calculator and the TI calculator, but I'm going to do all of them in the Desmos calculator. I'm going to show you one in both. So here, let me show you the TI calculator first. Okay, first thing, to get the square root, you will first press second, and then you will go down 1, 2, 3, 4 keys and hit that key. Now you have the square root, and then we will do 11, and you will press enter. Now you will follow this same step for the next 3 problems. So it says round to the nearest hundredth. The hundredth is 2 decimal places, so it'll be 3.32. So I'm going to write that approximately 3.32. Now, put in a Desmos. We could go here, square root symbol is here, and then type in 11. Gave us the same answer. Now we will hit the square root, go to 78, and that'll give us approximately 8.83 when we round. Then we'll go to square root of 99, be 9.95. And then the square root of 124, which would be 11.14. Now, if you notice here, this is 3.32. That is greater than 3, what the square root of 11 is. Square root of 78 is 8.83. It's less than 9. Square root of 99 is approximately 9.95, which is less than 10. And then finally, the square root of 124 is 11.14, which is greater than 11. So we definitely did those correctly. Now, the last part of section 1.4 is the group activities. Now, the reason why, and it's on page 49, the reason why, because in your syllabus, it tells you to pick a couple. So I'm going to pick the couple so you all will have a uniform problems. So the couple that I would choose is problem number 1, and then it'll be problem number 6, which will be on page 51. So let's look at problem number 1. It says, spend some time thinking about and discussing each question below. After talking with your group, make your best guess and explain your reasoning. Remember, these are supposed to be educated guesses, not shots in the dark. So think about using some basic calculations to help you. No using phones or computers to look anything up yet. Finally, after making your guess, write down some information you would need to know to find a more accurate answer. Now it says here, how many text messages do you send in a year? I put down that about maybe 1,500. It says reasoning. I do not text that much. Oh, you know what? I wrote this in the wrong area. 1,500 was supposed to go behind the question mark. And then I do not text that much goes under reasoning. Now, the information needed, I could check my cell phone bill, check my text, or call my mobile provider. Either one of those will get me the desired answer to this problem. Okay, now we're going to move on to problem number 6. It should be at the top of page 51. It says, how much time do you spend watching TV per week? I put 7 hours. And the reasoning, I don't have time to watch a lot of television. Information needed, time length of the shows I watch. So, you know, if you watch about 12 30-minute shows, that's 6 hours. So that is basically it for section 1.4. Now, let me just say this. The reason for the activity of you explaining your answer is preparing you for other problems that will ask you to explain your reasoning with your answer. So this is a good preparation, or it was a good preparation. So now we move over here to 1.5 on page 57. Now lesson 1.5 is of planes, boats, doll houses, and Dr. Evil. Learning objectives: to understand the meaning of scale in models and maps. Number 2, convert units using dimensional analysis. Number 3, view percentages in terms of scale. Now, for number 1 here, it says most people who pay any attention to the news are aware that the U.S. military uses drones, unmanned aircraft that patrol the skies over unstable regions, equipped with video and other surveillance equipment, and even weapons in some cases. These drones come in many different sizes, and the scale of a drone indicates its size compared to a similar full-size plane. For example, a half-scale drone is half the size of a full-size plane. List some other examples of where you've heard the term scale used in this way. So basically, I'll just name one. You could say model cars. You know, you could have a car that looks like a full-size car, and that's one. You do model cars. Okay, now we move on to the next page. It says the best gift I got for my birthday last year was my very own mini-me, not a living one, which would have been the best gift that anyone ever got for their birthday, but a bobblehead doll made to look like me. In case you're wondering, I don't wear shorts that short. This is in 1975. The scale for many objects is given as a ratio of two numbers. Ratios can be written either as fractions or using a colon. If a scale model is exactly half the size of the original, we could say the ratio of the smaller size to the larger is 1 to 2, or we could write that ratio as 1 over 2. My bobblehead is a 1 to 13 scale model, which means that the handsome little devil is 1/13 of my actual height. My mini-me is 5.82 inches tall. How tall am I? Okay. So, said this mini-me is 5.82 inches tall. Okay. Now the scale is 1 over 13. So we'll divide that by 1 over 13. So this would be 1 inch over 13 inches. Okay, so now we have to change this to multiplication. So it'd be 5.82 inches times, this would be 13 inches over 1 inch. Now, the one thing you need to know whenever you're dealing with scale is that, well, first of all, let's put this over 1 so we have a fraction times a fraction. When you're dealing with scale or dimensional analysis, which we will get to later in this section, you have to be able to simplify out units if you can. And in this case, you would simplify out inches. So 5.82 times 13 will give you, let's put that in a calculator, 5.82 times 13 will give you approximately, well, it'll give you exactly 75.66 inches, which is approximately 76 inches. As they say, round to the nearest inch. So your final answer would be this 76 inches. Now it says number 3, if the actual mini-me, 32 inches tall, had a bobblehead made at the same scale, how tall would it be? So the actual mini-me is 32 inches tall. We'll multiply by 1 over 13, or 1 inch over 13 inches. And then we would simplify out the inches. So this would give us 32 over 13 inches. We'll put that in our calculator. And that'll give us 2.46. Now they tell us to round to 2 decimal places. So that's why we would add 2.46 inches. Now it says, write a verbal description of the process from going from larger to smaller and smaller to larger when given a scale as in questions 2 and 3. So we want to go larger to smaller and then smaller to larger. Now let's look at what we did. We took this initial value and divided it by the scale. So this was actually the smaller, we were smaller here, and we were going up to the larger size. So smaller to larger, we would say we would divide the value by, well, I should say smaller value. We divide the smaller value by the scale. We divide the smaller value by the scale. Now, when we went from larger to smaller, we multiply the larger value by the scale. So again, larger to smaller, you multiply the larger value by the scale. Smaller to larger, you divide the smaller value by the scale. Okay, now we go here to the back. It says, here's a look at a map of the east of Dubuque, Iowa. It shows a driving path from a casino on the river to a golf course on the other side. According to the Maps app on my phone, the driving distance is 3 miles. We're most interested in the graphic at the bottom left, which indicates that 1 inch on the map, measure if you don't believe me, corresponds to 2,000 feet in real life. Okay, now we go down here to number 5. Points A and B are 4.06 inches apart on the map. How far is the casino from the golf course in feet and miles? The straight line distance, not the driving distance, which we already know. Round miles to 2 decimal places. So, we know we have 4.06 inches. And we're going to multiply it by the scale. Now, if you look here, this scale is actually in feet. So this is telling you that 1 inch is equal to 2,000 feet on this map. So we will multiply this by 2,000 feet over 1 inch. All right. So we'll put this over 1. These inches will simplify out because remember, we want our answer to end up in feet, and then we would end up changing it to miles. So 4.06 times 2,000 is 8,120 feet. Okay, now that is the value for feet. Now we want to change the feet. This is one of your answers. We want to change the feet to miles. So if we go back here to page 64, we have conversion charts here. Now this conversion chart, it tells you that 5,280 feet is equal to 1 mile. So that is the scale. So now we're going to take this 8,120 feet and multiply it by 1 mile over 5,280 feet. We'll put this over 1. The feet will simplify out. And this will give us 8,120 over 5,280 miles. Now we need to put this in our calculator. So we will have 8,120 divided by 5,280. And that would give us approximately, if we round to 2 decimal places, which they asked us for, it'll be approximately 1.54 miles. Now it says here, if we looked at a satellite photo at the same scale, could we see any boats on the river? If a 50-foot boat were on the river, how big would it appear on the photo? Round to 3 decimal places. Do you think you'd be able to see it? Okay, first of all, they told us it's a 50-foot boat over 1. Now, they asked us here, how big would it appear in the photo? Now, if it's a 50-foot boat, remember, 1 inch on here is equivalent to 2,000 feet. So these feet would simplify out. It'll be 50 over 2,000, which is equal to, well, it should be inches here, which is equal to 0.025 inches when you put it in your calculator. Now remember, this is what it will appear on the photo. Now you're looking down from a satellite. Do you think you would be able to see it? I would say no, unless the satellite zooms in. That's the only way we'll be able to see it. Now, number 7, it says write a verbal description of the process of going from larger to smaller or smaller to larger in questions 5 and 6. Now, if you notice here in questions 5 and 6, we didn't do any division. We just did multiplication. So at first we went from the smaller to the larger. So we went smaller to larger. We multiplied the smaller value by the reciprocal of the scale. Now larger to smaller, we multiplied by the scale. Okay, and when we talk about reciprocal, we know reciprocal just means that you're flipping the fraction or making the denominator the numerator or the numerator the denominator. Okay, now that took care of page 59. Now we're going to move on to page 60. Now it says here, in this tan box, it talks about the key idea in dimensional analysis. If measurements in two different units represent the same actual length, like 12 inches and 1 foot, then a fraction formed from dividing those units is just a fancy way to say 1. Now, let's look at an example. Since 1 yard and 3 feet are exactly the same distance, 3 feet over 1 yard is 1. 1 yard over 3 feet is 1. Now, that's just like this here. $1 over 100 pennies. They are exactly the same, so they equal 1. And even if you do the reciprocal, 100 pennies over $1 will also equal 1. Because we know anything divided by itself except 0 is equal to 1. Now, it says we call a fraction of this type a conversion factor. And multiplying any measurement by a conversion factor won't change the size of the measurement. And the reason being is because we know if we multiply by 1, it's not changing the number or the value of it. But it will change the units used to measure, which is exactly what we're trying to accomplish. Each unit conversion in questions 1 through 4 can have 2 conversion factors associated with it. Write the 2 conversion factors, and while you're at it, think about the fact that each is just another way to say 1. Okay, so we have 1 meter is equal to 100 centimeters. So one way we could put it is 1 meter over 100 centimeters. The second way we could do it is put the 100 centimeters over 1 meter. Next, we already did the 1 mile over 5,280 feet, or we could do the 5,280 feet over 1 mile. Next, we had 12 inches over 1 foot, or 1 foot over 12 inches. Here we have 1 inch all over 2.54 centimeters, or 2.54 centimeters all over 1 inch. All of them means the same. Okay, next, we move here to page 61. Okay, now it says the biggest challenge in converting units, like we did in the group portion of this lesson, using multiplication or division, is that it's easy to get confused over whether you should multiply or divide. Now it's time to unveil our clever procedure for converting units. To convert units using dimensional analysis, the goal is to multiply by a conversion factor in a way that makes the units we don't want divide out, leaving behind the units we do want. Okay, example time. The goal would be to convert 22 feet to inches. Earlier you wrote two conversion factors relating feet and inches. Below, multiply each of them by our measurement of 22 feet. So one conversion factor was 12 inches over 1 foot. The other was 1 foot over 12 inches. Now they tell us to multiply each of them. So we had 22 feet, we'll put it over 1, so we have a fraction multiplied by a fraction. The feet would simplify out. 22 times 12 is 264 inches over 1, which is 264 inches. So that's the first. So we'll put this over 1. Nothing will simplify out. So this would be 22 square feet, because it'd be feet times feet, all over 12 inches. And if you simplified that, that would give you 11 square feet over 6 inches without writing it as a decimal. Okay, now number 6. For each multiplication above, what would be the units of the result? Ignore the numbers and just look at the units. So we could say for number 1, or the first, well, I should say the first, would be inches. The second would be square feet over inches. Now we know according to this we wanted it as inches, so we know the first way is the best for this problem. It says in one of the multiplications above, the units that we did not want, feet, divided out, and the units that we do want, inches, were left behind. That's great because we multiplied by a conversion factor. All we really did is multiply by 1, which didn't change the size of the measurement. It just changed the units that it's measured in. And that, friends, is the point of dimensional analysis. Back to our calculation. How many inches is 22 feet? So we would just take 22 feet, multiplied by 12 inches over 1 foot, all over 1. The feet would simplify out, and that would be 264 inches divided by 1, or just 264 inches. Now, one thing I want to tell you as we go through this dimensional analysis is that to determine which one you're going to use, what you have to do is this here. Like we wanted inches. What we started off with was feet. So that would have to be in the denominator to get rid of those units. If we would have started off with inches, inches would have been in the denominator. But we'll take another look at that in just a second. Okay, now, here's the great thing about dimensional analysis. To do that conversion, you didn't have to figure out whether to multiply or divide to get from feet to inches. The units made that choice for you. And when conversions get more complicated, it can be really hard to just figure out what to do. That's what dimensional analysis is all. That's when dimensional analysis is almost essential. Let's say we want to convert the 3 miles of driving distance from the map in the group activity to yards. Why would anyone want to do that? Because they can. Okay, number 8. First, use your conversion factor from question 2 to convert 3 miles to feet. Okay, so we had 3 miles, and we'll put it over 1. And then we want to convert it to feet. So that means that miles will be in our denominator, and feet is 5,280 feet. We had already solved that 5,280 feet and 1 mile are the same thing. So that's the conversion factor. But we had to put miles in the denominator in order to get rid of the miles in the numerator. So miles will simplify out, and 3 times 5,280 is 15,840 feet all over 1. So it's 15,840 feet. Now number 9. Now use another conversion factor to convert the answer from question 8 to yards. Okay, so we have 15,840 feet, which we got here, and we want to convert it to yards. Now, if you look back on that conversion page, we know that it takes 3 feet to equal a yard. But let's look back on the conversion page. 3 feet is equal 1 yard. So we know the feet portion of this will go in our denominator and the yards will go in our numerator because we want to end up with yards. So the feet will simplify out. So we have 15,840 all over 3 yards. 15,840 over 3 will be 5,280 yards. Okay, number 10. Now here's a better idea. Convert 3 miles directly to yards by doing one two-part calculation. Again, focus on eliminating the units you don't want by putting that unit on the opposite side of the fraction when you multiply by your conversion factor. This is why we had you write conversion factor 2 ways. So you could get accustomed to the idea that you get to pick which unit goes on top and which goes on the bottom. Okay, so now we want to go from 3 miles to yards. So we'll put this over 1. So we know we'll change miles to feet first. 5,280 feet is equivalent to 1 mile. Then we would change feet to yards because it'll be miles will be gone, and then we need to get rid of feet. So it takes 3 feet to equal 1 yard. So the mile units will simplify out and the feet unit will simplify out. So this will give us 15,840 over 3 yards. And that will give us 5,280 yards. Now, number 11. It says, we've been focusing on units of length, but dimensional analysis can be used to convert anything that can be measured in more than 1 unit. There's a list of conversion factors on page 64. Use factors in that table to find how many cups are in a 2-liter bottle of Dr. Pepper. Round to 2 decimal places. So first of all, we're going to start off with 2 liters. Now, we want to know how many cups are in a liter. So we're using 2 different conversion systems. We had an English measurement system, and then we had a metric system, and then conversion between systems. So we had 2 liters, and the only thing that we have here in volume with liters is gallons and quarts. Now we don't need to go gallons because we're actually dealing in, we want to go to cups. So the first thing we should do is convert the liters to quarts. So now it'll be 1 liter is equal to 1.06 quarts. Now that we have quarts, we could change quarts to pints. You look here, 2 pints is equal to 1 quart. 2 pints is equal to 1 quart. Okay, now we want to change pints to cups. It takes 2 cups to equal 1 pint. We look back here, 2 cups equals 1 pint. Now we simplify. The liters will simplify out, the quarts will simplify out, and the pints. So we multiply straight across here, and that will give us 8.48 divided by 1, and it's cups. So it'd be 8.48 cups. Now we come here to the back. It says sometimes scale is described in terms of percentage. For example, for the filming of the Academy Award-winning film Titanic, a model of the stern of the ship was created at 12.5% of the actual size. Okay, so now we come here to problem number 12. It says a section of rail on the stern of the real Titanic was 24 feet long. How long was the corresponding section on the model used for the movie? Okay, so we add 24 feet, and then we'll multiply by the scale. The scale is 12.5%, which would be 0.125. Now your factor can be a decimal. So when we multiply this out, this will give us 3 feet. All right. Now, 13. It says, if an I-beam on the model spanned 30 feet of deck space, how big was the corresponding I-beam on the actual ship? Okay. So we have the scale, which is 0.125, or the factor, times x is equal to 30 feet. Now, x is the actual size of the ship. So 12.5% of the actual size of the ship is equal to 30 feet. So we have 0.125x equals 30 feet. We'll divide each side by 30 feet. And then we will have, oh, I'm sorry, not 30 feet, the 0.125. Divide each side by 0.125. So we will be left with x. And let's see if this is going to be approximation. So we have 30 divided by 0.125, which would be 240. So x is equal to 240 feet on the actual ship. All right, now we go down here to problem 14. It says, now let's turn this into a problem we already know how to solve, given that the model size was 12.5% of the real ship size. Write a reduced fraction that describes the scale in fractional form like we used earlier. Okay, so we have 0.125. We changed that percent, but we want to do it as a fraction. As a matter of fact, 0.125 is the same as saying 125 over 1,000. So we could do 125 divided by 1,000, which would be 0.125, but we would hit this key here, and it would give us the fraction. So this right here would be 1/8. Now, there was another way we could have done it, and I'm going to show you on the TI-84 calculator as well how you would solve this. You could, since it was 12.5%, we could take 12.5 and divide it by 100, because remember, percent means divided by 100, and then hit the fraction key, and it still gives you 1/8. So we could take 12.5%, which is 12.5 over 100, which is also 1/8. Now, the TI calculator. It doesn't matter which route you go, but if you did the 12.5 divided by 100, that gave you this decimal. You would hit math, and then you would see here where it says fraction, you would hit enter twice, and it gives you the fraction. Okay, 15. It says quick quiz. Is it illegal to make color copies of United States currency? Most people think it is. But that's not entirely true. According to the Counterfeit Detection Act of 1992, you can make color copies as long as they're less than 75% or more than 150% of the original size. Now it says write a reduced fraction like you did in question 14 to describe each of these scales in fractional form. Okay, now 75% is 75 over 100. And then we had 150% is 150 over 100. Now, remember this. It says that the size has to be less than. So we would do it like this. The size has to be less than. And then it tells you here that it has to be greater than 150%. So whatever we get, it must be written as you see here. So we could take 75 divided by 100. So that'll be 0.75. Hit the fraction, and it'll be 3/4. So it must be less than 3/4. And then we would do 150 divided by 100. And it'll be 1.5, but we're at the division key here. And it'll be 3/2. So it also must be greater than 3/2. Okay, now that took care of problem 15. Now we will go over here to problem 16. And this is the last problem for section 1.5. It says an actual bill measures 2.61 inches by 6.14 inches. So this would be 2.61 inches. And then this side here would be 6.14 inches. Now, are we in trouble with the feds for the reproduction below? Describe how you decided. Bonus points if you use the scale fraction. Okay, so basically, this right here is the real. I'll just put an R there to indicate that this is the real amount, or box this in for the actual dollar or the actual $100 bill. But if we were to take a ruler and measure this that's in the book, this side would be 4.19 inches. And then this side here will actually be I believe it's 1.88. Okay, so that is what this bill is. Now we want to find out if we would get in trouble with the law. So this is what we would do. Remember, it cannot be greater than, no, it cannot be, it has to be 150% larger or less than 75%. Now, if you look here at the real bill here, these two sides are less than that. So we only need to look up what it is for the less than 75%. So what we would do in order to do this, we would take each one of these sides here, each one of the real sides, the 2.61 and the 6.14, and multiply it by the scale factor we got on the other side, which is 3/4. Now, when you multiply that, so we would take this here, it's kind of cut off. All right, and we will multiply 2.61 times 3/4, which will give us, and we can round this off, it'll be approximately 1.96 inches. So far we're doing good. This is less than 1.96 inches. So far, so good. Now we would take this same problem here and we're going to multiply it. We're going to take the other side, which is 6.14, and then this would be approximately 4.61 inches. And if you notice here, this is less than a 4.61. So this is 1.88 inches by 4.19 inches. So we are safe because it's less than 75%. Okay, class, it looks as though we're going to go over 1.6 and possibly 1.7 as well. So we have 1.6, relatively speaking. It says the learning objectives is to compare difference and relative difference and understand why relative difference is often a more meaningful comparison. We have to apply relative error and then find conversion factors for square and cubic units. Now we look down here at the bottom. It says when asked to compare the sizes of two numbers, most people think of subtraction, but the example above shows that this isn't necessarily the best choice. The difference between two values is found by simply subtracting the old value from the new value. In both scenarios above, the difference is what was owed and what was paid is $10, which leads us to conclude the significance of that $10 is the same in each case. But doesn't it seem clear that the $10 shortfall is more significant when the total amount owed is $20? That's where relative difference comes in. The relative difference between two values measures the difference as a fraction of the original value. Okay, now we have relative difference, which is the difference over the original value. So it's the new value minus the original value over the original value. Now, if you remember back, I believe it was section 1.3, I do believe, when we learned percent of increase or percent of decrease, this is the exact same formula as percent increase and percent decrease. Now in scenario 1 above, the relative difference is 10 minus $20 over $20, which means that it's a negative 50%. The negative indicates that you got shorted. Okay, this shows that the difference between the amount owed and the amount received is half of the amount owed. That's a big deal. Okay, now we come here to number 1. Oh, and by the way, 1.6 was on page 69, and now we're on page 70. Okay, number 1, it says find the relative difference. If you win $5 million and get shorted by $10, write a fraction, not a decimal. Okay, so if you get shorted $10, that means that the new value would be $4,999,990 minus the original value would be $5 million divided by the $5 million. So this would be a negative 10 over 5 million. So this would give us a negative 1 over 500,000. Now, when you look at this, it says write as a fraction, not as a decimal. We're done here. Now, it asks us to convert this answer to question 1 into a percentage. So we could type in the negative 1 over 500,000. So in order for this to be converted as a percent, you have to move this decimal 2 places to the right. So it'll be a negative 0.0002%. So you know that's way different than losing 50%. It says compare the relative differences for the two scenarios in the opening paragraph from this lesson. Does this match your intuition about the scenarios? Yes. $10 loss from $20 is a bigger deal than $10 lost from $5 million.
I think the screen froze on the worksheet.
Oh, it froze. Oh. All right, let me see if it'll change up if I do this. Oh, no, it's not. All right, let me pause. Okay, class, we had a little technical difficulty. Screen that froze, but basically, this is what we had. When we took the -1 divided by 500,000, it gave us this negative decimal here, and we had to move it 2 places to the right, and that's how we get the negative 0.002%. And then for number 3, it says compare the relative differences for the two scenarios in the opening paragraph from this lesson. Does this match your intuition about the scenarios? I would have to say yes. $10 lost from $20 is a bigger deal than $10 lost from $5 million. Okay, now we go down here to number 4. It says, both Shauna and John found out that they're getting a $1,000 annual raise this year. John went out to celebrate, while Shauna yawned and said, yeah, whatever. Use the topic of this lesson to describe what you think might be likely to account for this discrepancy and their reactions to the news. I would think that John had a significant salary increase. But Shauna did not. I think that was the difference. Now, it could be argued that Shauna could have been expecting more or whatever, but I would just say outside looking in, I would suspect that that was a bigger salary increase for John. Okay, now we come here to the next page. It says your instructor tells you that you're going to get an additional 2 points on a recent test or quiz. Describe when this would be great news and when it wouldn't help very much. Going from a 68% to a 70% in the course. Well, on the exam. Okay, now going from a 4% to a 6% on the exam. And I should put down here great news. Not helpful. All right, number 6. It says the U.S. federal budget deficit for 2011 was about $1.298 trillion. This means that the government spent almost $1.3 trillion more than it took in. If you round that amount up to $1.3 trillion, which seems perfectly harmless, you cost the taxpayers of this country $2 billion. Said thanks. What's the relative difference between the actual amount and the higher rounded amount? Hint, if you're clever, you won't need to work with huge numbers. Discuss whether or not you think this difference is significant. It's up to you to decide and defend what you think significant means in this context. Okay, so we're going to take a look here. All right. It says we want to do the relative difference. And we know that formula is the new value minus the original value divided by the original value. Now, there's also another form of this formula. It's the estimate minus the actual divided by the actual. And I think this is the case here. So the relative difference, the estimate will be 1.3. Now, we don't have to write the word trillion because both of these have trillion behind them, so we know that this is in trillions. So it's 1.3 minus the actual is 1.298 divided by the actual, 1.298. So this will give us 0.002 all over 1.298. So when we divide this out, this will give us 0.0015. And let me put this in a calculator just so you can see it. 0.002 divided by 1.298. Oh. And so we rounded to 4 decimal places, but we will write, and it's an approximate, we'll write this as a percent, so it'd be 0.15%, because relative difference is typically written as a percentage. Okay, now, number 7. It says a college football team won 5 games and lost 7 in 2014. Then turned that around, winning 7 and losing 5 in 2015. At the same school, the basketball team won 10 of 34 games in 2014, then won 15 of 34 the following year. Which team had the more significant improvement? Discuss and back up with evidence. So we have relative difference. Again, we have new minus the original divided by original. Okay, so we want to look at their improvement. So we're going to take a look at their wins. So they first won 5, then they won 7. So we will have 7 minus 5, because 7 is the new value, 5 is the old value, divided by 5. So this would be 2/5. And in our calculator, this would be 0.40, which is 40%. Okay, now we will go to the basketball team now. This is football, and this is basketball. So the relative difference, the new value is 15, the old value is 10, divided by 10. So this will give us 5 over 10, which is 0.50, which is 50%. So the basketball team did better. Okay, now, one thing I didn't do back up in problem number 6. We were supposed to tell if this is significant. Now, this is less than 1%. So I would say that this isn't significant. So I would say it is less than 1%. So not significant. Okay, so now we're going to move on to the next page. Okay, on the next page, we will start up here with problem number 8. It says, in my Calc 2 class yesterday, we were doing approximations of various outputs using advanced calculus techniques. Anyhow, in one case, the approximation was 1, while the exact value was 0.406. In another case, the approximation was 21, while the exact value was 22.176. Which was the worst approximation? Use the techniques we've used in this lesson. Show our work and write a sentence or two explaining your choice. Okay, so we know we would do relative difference, and we know we would do the estimate minus the actual divided by the actual. In the first case, the estimate was 1 and the actual was 0.406. Now, in the second scenario, the estimate was 21 and the actual was 22.176. Now, when we put this in our calculator, it'll be 0.594 divided by 0.406. Down here, it would be a negative 1.176 all over 22.176. Now, we could put these in our calculator. So we would have 0.594 divided by 0.406. So if we round the two decimal places, it'll be 1.46. But remember, relative difference is typically written as a percentage. So this would be 146%. Now we go down here. We have a negative 1.176 divided by 22.176. So that would be a negative 0.05. And we can go one more place, 3. Then when we round this, this will end up being a negative, change this to a percent. It'll be a negative 5.3%. Now they ask us which one of these is more significant. Well, actually, no, they don't. Okay. So this is basically it. Oh, it says, which was the worst approximation? So we need to write a sentence or two. I would say let me see, which one was it? The second case was the best approximation because it was only 5.3% off, whereas the first case was 146% off. That's a big difference. All right, now, I'm trying to look here. For 1.6, we had 3 more pages to go. I want to look here at 1.7 to see how many pages we have for 1.7 to see if we could complete that. Okay, there's only 4 pages for 1.7, so let's see what we could do. All right, we go back here to the next page, 73. Now it says, using professional guidelines, an installer estimated that 24 and 2/3 square yards of carpet would be needed for the bedroom and closet shown in the diagram. So number one, it says find the area of the bedroom only in square inches. So we have, first of all, area is equal to length times width, because we're talking about a rectangle for the bedroom. So if we do length times width here, we would have 171 inches by, or multiplied by, the 138 inches. So your area here would be 23,598 square inches. That would be your area. Okay, now it says find the area of the closet in square inches. So we come here to the closet. The area is still length times width. The area is 64 inches times 50 inches. 64 times 50 will give us 3,200 square inches. So that would be the area of the closet. Now number 3, it says each of the doorways shown is 32 inches wide and the walls are 4 inches thick. Carpet is needed for the entire doorway between the bedroom and closet, and a half of the doorway into the bedroom. How many square inches does this add to the total carpeted area? Okay, so we would take 32 times 4 plus 32 times 2, and that would give us 192 square inches. That's how much is added to the total carpeted area. Now number 4, we know that there are 36 inches in 1 yard. How many square inches are there in a square yard? The diagrams below should help. Okay, first of all, 36 inches is equal to 1 yard. That was given to us. Now they're asking us how many square inches are in a square yard. So what we could do is we could just take both sides to the second power. And if we do that, that'll give us 1,296 square inches is equal to 1 square yard. Now, when they said that this diagram would help you, 1 yard times 1 yard would be 1 square yard. 36 inches times 36 inches will give you the 1,296 square inches. Now we come down here to number 5. It says use the conversion factor you developed in question 4 to convert the total carpeted area to square yards. Round to 1 decimal place. Okay, so first we would take this value here, which is 23,598 square inches. That's the value from the area of the bedroom, plus the 3,200 square inches for the closet, and then plus the added on value, the 192 square inches. When you add all of these up, it'll give you 26,990 square inches. So now they want us to convert this to square yards. So we had 26,990 square inches. We'll put that over 1. Multiplied. It takes 1 square yard. Well, 1 square yard and 1,296 square inches are equivalent. So the square inches will simplify out with the square inches and leave us the square yards. So this would be 26,990 over 1,296, and this would be square yards. Now, when you divide this out, it will give you an approximation of 20.8 square yards, because they asked us to round to 1 decimal place. Now, we move on to the next page for number 6. It says, if we multiply the total square inches you used in question 5 by the conversion factor, hold on one second. I think that was a telemarketer, but let's go here. To understand the significance of questions 4 and 5, let's suppose we didn't have a conversion factor for converting square inches to square yards we developed in question 4. Another way to say square yards is yards times yards, and square inches is inches times inches. With that in mind, if we multiply the total square inches you used in question 5 by the conversion factor 1 yard over 36 inches, what sort of units will remain? So we had 26,990 square inches. We'll multiply that by 1 yard over 36 inches. Now, just to let you know where we got these numbers from problem number 5 on the previous page, this was the total amount of carpet that we need. And then also the conversion factor, we basically had up here 36 inches equal 1 yard. So this is where we got these values from. So we'll put this over 1. Inch and square inch will simplify out, but you still will be left with an inch here because it's 2 of the, it was 2 of these. So then this will give us 26,990 over 36, and this will be inches yards. And then your final answer, I think they asked us to round to 2 decimal places. So I'm assuming we're rounding to 2 decimal places. So it'd be 749.72 inch yards. Okay, now it says, what if we multiplied that result by 1 yard over 36 inches? So we have 749.72 inch yards times 1 yard over 36 inches. Now, the inches will simplify each other out. So you have 749.72 square yards all over 36. Now, when you divide that out, we round to 1 decimal place, like we did in the previous problem, it'll give us 20.8 square yards. Now, we move on to problem number 8. It says, now let's use some estimation skills to see if your answer to question 5 and 7 is reasonable. Because if it's way off, that'll totally mess up the rest of this activity. The bulk of the area comes from the bedroom, right? Find the length and width of the bedroom in feet, round it to the nearest foot. Then divide by 3 to convert to yards. Again, round it to the nearest yard. Finally, use these measurements to get a rough guess of the bedroom area in square yards. If you have the wrong conversion factor in question 4, or did the conversion wrong in questions 5 through 7, the number of square yards you got will probably be radically different from the estimate in the question. If so, figure out what you did wrong in 4 and or 5. Okay, now, it was 171 inches, and then we also had 138 inches. That's what we initially multiplied. Now we're going to multiply by the conversion factor. It'll be 1 foot over 12 inches. So remember, we're trying to get to yards. So put this over 1, put this over 1. The inches will simplify each other out. So yeah, 171 over 12 feet, 138 over 12 feet. And this will give us 14.25. And this will give us 11.5. And they tell us to round to the nearest foot. So this will be 14 feet. This will be 12 feet. Now we want to convert these feet to yards. So we have 14 feet times 1 yard over 3 feet. These feet will simplify out. You have 14 over 3 yards, which would be approximately 4.67, which is approximately, well, we could just say that it gives us 5 yards because we're told to go to the next whole number yards. Okay, so now we had 12 feet times 1 yard over 3 feet. We'll put this over 1. These feet will simplify out. This will be 12 over 3 yards, which is actually just 4 yards. So we don't have to do anything to that. So now we will see how many square yards this is. 5 yards times 4 yards is 20 square yards. So it is close to what we had because up here is 20.8 square yards. And down here we had 20 square yards. So we are very close. Okay, now we come here to the next page. Page 75. It says write a sentence or two describing how the professional estimate compares to the actual carpeted area. Okay, now the actual area was 20.8 square yards. The estimate, which was given to us, and I'll pull this back here. This is the estimate, the 20 2/3 square yards. So, the 24 2/3. So it'd be 24.7 square yards if we round to 1 decimal place. Okay, the estimate is almost 4 yards or 4 square yards larger. Okay, now we come here to number 10. It says find the relative difference between the estimate and the actual area of the carpeted portion of the room. Round to 2 decimal places. Write a sentence explaining what this tells us about how the estimate compares to the actual carpeted area. Write the relative difference as a percentage. Well, writing the relative difference as a percentage is a good idea. Okay, so we have relative difference. We know the estimate minus the actual divided by the actual. So the estimate is 24.7 square yards. The actual is 20.8 square yards. And it's all divided by 20.8 square yards. Now we'll put that in our calculator. So we have 24.7 minus 20.8, which gives us 3.9 square yards divided by 20.8 square yards. And then the square yards will absolutely simplify each other out. So now we would take 3.9 divided by 20.8, and that gives us 0.1875. So if we wrote this as a percent, it would be 18.75%. So that is the difference between the two. Now, so we could say the estimate is 18.75% larger. Okay, now number 11. Now everyone realizes this, but when you buy carpet, you pay for the estimated amount, not the actual amount covering your floors. If the family that owns the house in the diagram picked carpet that costs $28 per square yard installed, how much would they have paid? So we would take the $28 and multiply it by the estimate of 24.7. So yeah, 28 times 24.7. So that would be $691.60. That's how much they would have paid. Now it says use the actual difference. Now this isn't relative difference. So it says use the actual difference between the estimate and the carpeted area to find the dollar value of wasted carpet. Now we already determined that it's 3.9 square yards more than what we need. So we'll take 3.9 and multiply it by $28. So you would pay an extra $109.20. That is a lot of money to pay on something that you're not even going to use. Okay, next. Percent error plays a really important role in the sciences and engineering. In electrical engineering, for example, much of the equipment used in transmitted power is rated for a certain amount of voltage, amperage, or resistance. Systems are designed so that fluctuation in these values can be absorbed without damage, as long as those fluctuations are within a certain range. These ranges are measured using relative error. Suppose that one transformer is designed to handle a maximum of 2.4 megavolts, and it has the ability to handle a 15% overage. If the voltage spikes at 2.91 megavolts during a power surge, can the transformer handle this? And it says, show your work. Okay, so we could take the new value, which is 2.91, minus the original value, which is 2.4, divided by 2.4. When you put this in your calculator, you have 0.2125, which is 21.25%. And that would be your overage. So the transformer cannot handle this. Okay, 14. Based on question 13, it would seem to be a natural question to ask exactly how many megavolts the transformer can handle without sustaining damage. We can use some algebra and the calculation above to figure that out. Using a variable V for the voltage and 0.15 for the relative error, set up and solve an equation that tells us the voltage that corresponds to a 15% overage. So the new value, which would be the 15% overage, minus the original, divided by the original. And it's supposed to equal to 15%, which is 0.15. So we're trying to do all this to get V. So we will multiply each side, or everything, by the 2.4. These 2.4s will simplify each other out and leave you V minus 2.4. Then 2.4 times 0.15 is 0.36. So we would add 2.4 on both sides. So your voltage can only go up to 2.76 megavolts. Now for number 15, it says list some situations where relative difference is a much more useful number than actual difference. So basically, I'm going to give two scenarios. Losing $1,000 is a really big deal if you only make $1,500. Okay. Number 2, getting shorted 5 minutes of a 30-minute doctor visit getting shorted 5 minutes of a 30-minute doctor visit as opposed to getting 5 minutes cut from a 2-hour doctor visit. Now, I did not put the comparison for problem number 1. So this is losing 1,000. This would be a really big deal if you only made 1,500. But if you made $5 million, not so much. Okay, so we're going to stop here. So that would take care of 1-6 as well. All right, I hope you all have a very good weekend, and I will see you next Tuesday.